thank everybody for coming. In case you don't know where you are, we're going to be talking about Apache Metron today. I am Casey Stella. I'm a principal software engineer here at Hortonworks, and I'm the VP of the Apache Metron project, in addition to a PMC member and a committer. So first off, before I start, I want to know, so this is a cybersecurity talk. It's also a streaming analytics talk. So how many of you guys are in cybersecurity in some capacity? All right, so cybersecurity professionals. How many of you are here to hear me talk about streaming analytics? So some overlap. Probably should have figured out how to avoid the intersection there, but that's great. That's great. So so hopefully it'll be a little bit for everybody. So you're going to hear me talk about how we've scaled out being able to do non-trivial analytics on Metron. Right? For those of you who are trying to kind of roll your own, this is I want you to treat this as a cautionary tale, right? This is, but it's a good tale, I would say. So first, let's talk about Metron. So Metron is a cybersecurity analytics solution. We provide a scalable, advanced security analytics framework on top of the best-of-breed big data technologies. So ultimately, this means that we provide a solution to ingest, enrich, and detect anomalies from disparate data sources, and enable security investigators and researchers and analysts to look at those anomalies and find other things that happened that are similar, right? Those are the kinds of use cases that we're talking about. So think, I need to ingest DNS logs. I need to ingest NetFlow data. I need to ingest my application logs. I need to ingest my HTTP logs. I need to analyze packet capture data, raw PCAP data. All of those are within the purview of Metron, right? So Metron started, to understand kind of the Metron journey, it's important to understand how we started. So Metron was initiated at Cisco in 2014. They talked about it here a few years ago. I attended the talk. And they called it OpenSOC. And they open sourced a version of OpenSOC, and they closed sourced some of it, and they provided a product offering around it. So in 2015, Hortonworks contacted Cisco and said, okay, look, Hortonworks and a number of other vendors said, hey, let's open source this, right? Let's put this in the Apache Foundation because we believe in community over code, right? We believe that it's time for a cybersecurity solution that's community driven and community oriented, right? There's no reason to have, for everyone to be doing this exactly the same, plumbing and infrastructure and all this stuff, right? Because it's clear that cybersecurity is a big data problem, and it deserves a big data solution. So Metron was submitted to the Apache Incubator in 2015, and we graduated. We're very proud of this. We graduated in 2017. We were aggressively pushing toward graduation all the way to that point. We've had a number of releases, including being run in production by a number of different places. So it's been a journey, and we're very proud of our what happened there. So what does the stack look like? What are we doing? Our VP of product management laughs and says, you guys are like the pet store app for Hadoop. Like there's not a product that we construct, there's not an Apache project that we ship in HTTP or HDF that you guys do not integrate with and use. So we're aggressive users of Zookeeper. We're aggressive for distributed configuration management. We're aggressive users of Storm. We're aggressive users of HBase, so in non-trivial ways. We have MapReduce jobs. We have Spark jobs. We have, where appropriate, we use HDFS for long-term storage. We index near-term storage or hot storage for these values in Apache Solr and Elasticsearch. We use Kafka, or Kappa architecture, right now, moving on our way to a Lambda architecture. If you're curious about that journey, come find me afterwards. We can talk. And on top of all that, we built a UI, because ultimately, we are a cybersecurity solution. And a solution is not just a construction of Apache projects. A solution is something that helps security analysts find bad guys. It helps people find anomalies, right? So all of that, I say inside of DataWorks Summit, because most of you guys are Hadoop people, right? So speaking of UI, this is what the UI looks like. I apologize, it's dark themed. It's hard to see, but that's what they decided. All right, so this is what the UI looks like. So the idea here is that you want to be able to look at alerts. And by alerts, I mean data that is coming in that looks anomalous, and you want to serendipitously find other kinds of alerts and analyze it. All right, so specifically, we're looking at these anomalous alerts. So the score column there indicates that, hey, we think that something went wrong. We have analyzed the record. We have brought to bear as much context as we can. We've integrated, we've said this is a record, this is a DNS record that goes to this URL. We've extracted the domain. We've bounced it against our typo squatting model. We've bounced it against our DGA model. We said, okay, this looks suspicious. Something is happening, right? We've enriched it with machine learning models, asset databases, just simple key value lookups, whatever. When we've made a decision that this looks like an anomaly. It may be a false positive, but the confluence of reasons come to bear that indicate that this is a threat and the score is that, right? And it allows us to look and say, all right, this is a threat because of this reason. Okay, so for specifically, and I'm going to go in slightly more deep here than I did in my previous talk yesterday, because this is the kind of analysis that you typically see. So a lot of SIEMs and a lot of other solutions really focus on rules, hard-coded rules. We try to make more adaptable rules, and there's a couple of different ways to do that. And when I say more adaptable rules, I mean not necessarily even rules at all sometimes. In particular, this case, this data set is from Los Alamos National Labs. And Los Alamos National Labs opened a data set of their authentication records, their NetFlow records for like a year for their internal network, depersonalized, et cetera. We like to analyze that inside of Metron because it's nice and open. You don't get a lot of open cybersecurity data sets to show off. And they also have red team events. So they determined that at this time, from this machine to this machine, user X broke in, right? So we analyze this and try to figure out, okay, can we recover those red team events, not knowing about it, right? And this one in particular was a volumetric anomaly detection using what we're going to talk about today, the profiler. So the distinct number of machines that this user connected to is more than 5 standard deviations away from the median or the mean or whatever, right? That's the kind of, when I say adaptable rule, instead of this user connected to 5 machines and 5 distinct machines, and that's more than I've determined is too much. The number of times that I've mistyped my password is 10, and therefore it's an anomaly. What we find is that it's better to let those rules be data-driven based on behavioral analysis rather than hard-coded and fixed. So this is one way to do that. Statistical baselining is on volumetric data in particular, volumetric baselining. The problem is, how do you do that at scale? How do you do that in stream? That can be difficult because you have a lot of things to consider, and we'll talk about that in the course of this talk. So really, at the end of the day, you're only as good as the context you can bring to bear on the message. So streaming analytics is hard. I was really interested in the keynote today when they talked about the number of people on that streaming analytics journey and how few people are how many people are, the volume of people who are just kind of taking a step down that path. And it's because in order to make good decisions, you really need to bring as much context to bear. And that context can be, so really that's what enrichment is in Metron. So this is a matrix of all the different ways that you can enrich a message in Metron. So you ingest an event, and you want to bring as much context to bear. So at the top, if you have static or slow-moving enrichments, think like an asset database. Maybe you add a machine every month or every week or every day that's relatively slow moving in relation to your data, which may be coming in at a gigabit per second, right? So we can do batch enrichments into HBase because the semantics are key value lookup. I see this IP address, I know this IP address is a web server, is a DNS log, or is a DNS server. That's important because what kind of server that machine is will dictate how it's supposed to behave. So I can do segmentation, right, effectively. So if I also have static, slow-moving data and the scope of an event, and I have something that's complex, we can use the summarizer. So if you went to my talk yesterday, we talked about how to use the summarizer to construct a Bloom filter that would allow you to do typo squatting at scale, in-stream, typo squat detection. If you didn't go, which is fine, you can catch that later on. But if it's changing dynamic, and you also need a key value lookup, you can actually stream that data into Metron and have it update in HBase. So think in terms of, I have authentication records. I want to know I want to know what's the IP address for user A, right? Because I'm getting data over here in NetFlow that's only IP addresses, not users. But I want to do user behavioral analytics, so I need to associate the user or the likely user. So I'm streaming authentication records in, and it's updating HBase so I can have that key value lookup. Given this IP address, what's the possible set of users? Or what's the actual user, depending on what kind of logs you're pulling in. And if you have static and slow-moving data, but you have more complex retrieval semantics, like I have a URL, I want to extract the host. I want to determine if that's from a botnet, right? So I have a DGA model that my data scientists have constructed. I want to be able to deploy that model. So again, keynotes are important here. When we heard the Teradata guy talking this morning about the challenges, it's around things like deployment, things like construction of your models. But once you've constructed your model, it's important to be able to deploy that and call that model at scale. So Metron's constructed infrastructure around deploying machine learning models without forcing you to use Spark, without forcing you to use the tooling that we decide that you want to use, that you need to use. If you build your model as a REST interface, you can deploy it on Yarn, you can deploy multiple copies of it, and you can interact with that model as the data streams by, right? So deploying at scale and analyzing at scale, right? That's an important, complete picture of how we do enrichments. And finally, and this is what this talk is focusing on, if I have dynamic, quickly changing data and the scope is outside of the event, I can use the profiler. So what's the profiler? The profiler creates logical windows. So the idea is that I want to take, in these windows, I want to analyze those streams. The green stream is a stream of data. Let's say that's DNS logs. The blue streams maybe is NetFlow. The orange stream is perhaps some other data source, right? I want to be able to summarize. I want to be able to capture summaries at time windows so that I can trend across time. So for anomaly detection, I want to be able to understand historical behavior. In order to do user behavioral analytics, you have to understand how the user behaved in a segmented way, stratified, how this user behaved with regard to this machine, with regard to that, over time. And this is a way to do that. So what the overall architecture, if you take one picture in this, take a picture of this deck, because this is the key, right? We store summaries and sketches in HBase for retrieval. So that's the right side of it. The read side of it is actually more important. It's the part that I'm actually the most proud of. We aggressively decouple the configuration for reading and writing. It was a core tenet of our philosophy. So we capture these sketches per window, and we can retrieve them. But the retrieval has to be able to be an honest analysis of a time series event for a user. It has to be able to handle seasonal adjustment. And what I mean by that, what I mean is your network and your users are going to behave differently at 9 a.m. on a Saturday versus midnight on a Sunday. Including the time at midnight on a Sunday is going to skew your medians and your standard deviations and the statistical baselining that allows us to do that first authentication analysis that we done in Los Alamos National Labs, right? So we need to be able to have a complex temporal seasonal adjustment at read time. We don't want to define it at write time because we don't want to have to go back and rewrite all of our data. We want to be able to do it as the data streams by without having to rewrite. And we use HBase and Storm and Kafka. Okay, so we're going to provide, there's two different types of query semantics. The most common is a fixed lookback, and that's what you're going to see. So the last 1 hour, right? Automatically seasonally adjusted, whatever, last 1 hour. The more complicated one is a seasonal adjusted window. So the bottom here, we have a couple of examples of those queries. Those are actual queries that you can run, right? So from 1 hour ago, that's equivalent to 1 hour lookback. From 1 hour ago until 30 minutes ago. I want to skip the last 30 minutes. I just want to consider 1 hour ago. So essentially from an hour and a half until 30 minutes from the current point. So this is always in relation to the data time, right? So the time that you see the actual data. And more complicated ones. Well, I want a 1 hour window every 24 hours from 56 days ago. That's a long look back. Including this day of the week, excluding US holidays and weekends. That's really the key, right? That's how you build a more fine-tuned model that allows you to squeeze more out of statistical baselining in a scalable way. Okay, so how does that work underneath the hood? The profiler constructs these sketches, and we construct an H-based key. Those queries, because it's every k minutes, those queries are going to take that temporal range, and it's going to say, all right, what keys do I need to grab? And it's going to do a multi-get, and it's going to do that in parallel. That's the way that scales, right? So you're using HBase, which is a scalable store, and you're using a multi-get, which is a scalable approach. It's a scan-free architecture, for those who wanted to talk about HBase architecture, and the keys are uniformly distributed, so there's no hot spotting. That's, at the end of the day, the approach. Okay, so now what do we store? You saw me talking about medians and standard deviations and random percentiles, right? How do you do that? So I can grab all of these things together. So I have, for every 15-minute window for that 56-day time range, what am I going to do with all of those? Am I going to ask each of them what the median is and just somehow sum them up? No, what we do is we use data sketching. So approximate probabilistic algorithms and data structures in order to store that data in a scalable way. So the idea is you don't want to use data structures that scale linearly with the number of events that you see. You want to use data structures that are O of 1 in terms of data storage and have the following characteristics. So the mathematician in me says that they form a semigroup, which is to say that the query of the sketch of the data plus the sketch of the data at a different time is equivalent to the query of the sketch of the data together. So it's as if I shoved those data together and then took the sketch is equivalent to taking the sketch and merging the sketch. So in other words, the way to think about this is all of this infrastructure is mergeable. So things that support that, statistical questions, things like medians and percentiles and standard deviations, right? Arbitrary percentiles. If it was just asking things about means, it would be relatively simple, right? That's easy to merge. It's when you start talking about, I want to know the 95th percentile of this and compare it. I want to do a interquartile range, that kind of thing. Set operations, containment, set existence, set containment with Bloom filters, set existence with set existence with existence containment, same. Anyway, cardinality with hyperlog log plus, that kind of thing. Sampling, if your algorithm does not support these kinds of queries, you can do uniform sampling and merge the samples together and do other kinds of things with it in scale. Okay, or in stream, I should say. So it can persist anything. Those data structures are one thing that the profiler can persist. And this is really the key, right? It allows you to persist these sketches and recover those sketches and merge them together to ask questions about that merged. So what does it look like? So let's look at an example of a profile. So one thing I want to say is that Metron does have a UI. We don't have a UI for constructing the profiles yet. Keep in mind, this will become a hell of a lot easier in the future going forward. Much less JSON in your life, I promise. But for the purpose of this talk, let's talk about what this actually is. So in this situation, I want to grab the profile called HTTP length. and I want to grab the length. What I'm gonna try to understand is the distribution of the length of a URL, right? So I'm pulling data from Bro, and it's HTTP data, and I'm gonna update the statistical sketch for the distribution with the length of that URL, right? And then at the end of the day, I'm gonna store off that sketch. So we could go over 1 million distinct URLs, and the size will not scale linearly with the number of things that it saw, right? And then I'm going to grab it. I'm going to say, OK, let's take a look. And I'm going to call profile get. So all of this is in Stellar. So Stellar is our glue together language for doing rules and interacting with Metron at a high level, right? Interacting with all the infrastructure inside of Metron, including the profiler. So I told you, I pulled back the curtain a bit and said, this is HBase, this is this, this is that. You don't, as a user, you don't have to know any of that. You just need to be able to call profile get. For the last 24 hours, I want to grab the HTTP length profile, and the entity name is global. So I want to grab the global distribution of all the HTTP, all the URLs from Bro. And it's going to give me back a list of those profiles. And a list of the distributions is not necessarily useful. What is useful is the one on the right there. I can merge those distributions and ask questions about percentiles, ask questions about medians, ask questions about standard deviations, right? OK. Or I can ask it about just the first one, if I want the most recent one. I grab the first one on the list and say, OK, look, the first one for that 15-minute window is the length is very high, like 15,000 characters or so, right? For the mean. But if I look over the entire time, the 90th percentile, it's 30,000. The 90th percentile is lower, slightly lower, right? So the more data you bring to bear, these baselines change, okay? Okay, so let's kind of make this a little bit real with a use case. All right, so let's talk about an anatomy of a solution. So one way to find anomalous behavior on a network is to monitor the locations that the user logs in. So if a user logs in San Diego and the user logs in Russia and within a 2-minute window, maybe that's weird, right? I was talking to a friend of mine earlier, and he said, what we did was kind of, I was talking about the solution. He said, what we did was kind of similar in a previous company. What we did was we calculated the difference. We calculated the distance between the 2 points, and then we would say, all right, if you traveled on a jetliner, it would take you this long. The difference between the 2 times of login, is it longer than it would take you to fly to that point, right? And so we thought we were pretty clever, but then we realized that people were logging into their bank accounts and then logging in with BlackBerries, which essentially was constructing like a VPN into Toronto. So you would be in San Francisco, and it looked like you were in Toronto within like a couple of seconds of each other. So I just wanted to say that that's an illustration of a clever rule, a way a clever rule can construct a false positive, right? So let's try to avoid that slightly. So what if instead we track the distribution of the user's distance from the geographic center of previous login events? So I track the user's login over time, and I say, OK, this is the geographic center. This is kind of the centroid of where this person's logging in. And for every login, I want to calculate the distance between that centroid for like a rolling window, right? And then I want to understand that it's an anomaly whenever a user is more than 5 standard deviations away from that centroid, right? Are they acting differently? So it's pivoting the question from, is it possible for this user to do this, to is this user demonstrating behavior that is different than usual? For instance, if that user always logs in to Chase, right, via his or her computer, and it looks like they're in San Francisco, and they immediately check with their BlackBerry, if they do that, the centroid is going to be the median point between Toronto and San Francisco. If they do that a lot, the centroid is going to shift toward Toronto slightly. So you get a softening effect of that rule, and you start pivoting it about user behavior rather than hard rules, which is the key to Metron. Okay. So we're going to go in fairly deep here. So this is a Metron architecture is first we parse the data, then we enrich the data, then we profile the data and index the data. So what we're going to do is we're going to show this is authentication data. It has a user, an IP, and a timestamp, 3 fields. Very, very simple, right? Gend up data. And in that, I'm going to enrich it slightly, a simple field transformation. And I want to, and this is stellar, this geohash from LOC. I'm going to take the IP address, and I'm going to get a geohash of it, because we have a lot of geohashing capabilities inside of Stellar, because it's a fairly common thing to do, beyond just profiling, right? You might actually want to have that rule that I just described about the, and you can do that in Metron too. Okay, so once we've done that, we have staged our base data. We're going to create a profile, and I want to create a profile that tracks user login behavior. And I'm going to create the profile per user, right? So, but keep in mind, what if I didn't want to create the profile per user? What if I had enriched my data from an asset database that said this user is a sysadmin, and I know my sysadmins use VPNs and they have weird behavior. I want to consider that. I want to consider, and I know my system or my team is based here, right? If I wanted to segment that in a different way than per user, you can do that too, right? But for our purposes, we're going to do it per user. So we're going to compute a profile for all the users that actually have a hash. Let's say they went to an IP address that didn't actually exist or it was bad data. Metron, you want to be resilient to bad data, because bad data happens in the real world. What I want to capture is a multiset. So that's a hash to the number of a geohash associated with the number of times that it occurred. That's enough information for me to calculate a centroid, or the median distance, right? Okay, so the first thing I'm going to do when I enrich my data, so it's going to be it's going to be 2 passes. The first thing I want to do is grab the geodistance out of it. So this is the distance from the geographic center. But first I need to understand so this is an event that flows in, a user is authenticated. The first thing I want to do is I want to grab the geographic center for that user for the last 4 hours. Let's say that's not 4 hours. Let's say that's a more complicated query, right, where it's the last hour, skip 24 hours for the last 6 months to get a really robust seasonally adjusted one. But for this, we'll say the last 4 hours. I want to calculate the centroid, and I want to grab the distance. Okay? What I really want to capture is that last field, the geodistance. And I'm going to set up a second profile, and I want to baseline across all users. Or let's say I want to baseline that across just an individual user role. Maybe sysadmins behave differently than everybody else. This is a baseline across all users. So to say, every user is going to have this particular characteristic. Okay. So I want to gather the statistical sketch of the geodistance. So that's the distance from the centroid. I'm going to go back. And in my threat intel section, so when we do enrichments, there's 2 phases. First is enrich the data with as much context, and a second is a second enrichment that happens after the first enrichment that's aimed at enrichment specifically for threat intelligence, right? I want to make a decision about this user. Is this a threat, or about this event? Is this a threat? Is this not a threat? Okay, so this could be made shorter, but I wanted to be verbose, as verbose as possible. So I want to grab the distribution, the statistical sketch across time of the distances from the centroid for each user, and I want to grab the median of that. And I want to grab the standard deviation of that, and I want to understand if it's an outlier is when the distance between the median and my distance is more than 5 standard deviations away. So simple statistical baselining. And I want to determine if it's an alert or not. So I'm going to set a field called isAlert. And if isAlert is set, it's going to show up in my UI, and I'm going to give it a score. Okay. But in order to explain to the user what this actual thing means, I need to construct a rule here that says, all right, if I'm a geographic outlier, if I'm a geo outlier, I want to give a nice reason user X has distance X, or has distance Y from the centroid of their last login. It's 5 standard deviations away from the median. That way the analyst knows, oh, okay, this is why this person is showing up on my screen. So let's say the analyst looks and he says, you know what, that's not sufficient reason. So imagine in Metron, you can have multiple different ones of these. So you bring as many different, so the idea is some of these rules are going to be, no matter how adaptable you get, whether it's a machine learning model or otherwise, these rules are going to have some false positives. You want to zoom in as much as possible on false positives, but you also don't want real, true positives to slip through your fingers either. So what you do is you build a bunch of relatively soft rules with some false positives together, and you let the plurality of data, the plurality of the risks bump the score up so that you see, okay, this is a geographic outlier, and in this user also did this other thing, and he did this other thing, and he did this other thing. That's a guy that I really want to care about, right? Versus, okay, it's a geographic outlier, but maybe it's not that big of a deal, right? Okay. But you want to give the analyst as much information as possible. So, in conclusion, really, what I've talked about here is ways that Metron can construct in a scalable way. Methods to do statistical baselining, other kinds of analysis, using other kinds of temporal analysis and outlier analysis using the profiler. There are other approaches to this. We have, for instance, if you don't like statistical outlining, we have outlier detection, and we have median absolute deviation, which is another riff on that. We have more complicated algorithms, but honestly, a lot of times this gets you very far, and it's nice and understandable and easy to explain to the user. So this is the same kind of technique we used in the beginning with the authentication data with Los Alamos National Labs. And with that, I'll take questions. I have about 10 minutes for questions. So, yes, sir?
So one of the questions has been learning. I actually been working on a Metron system.
Awesome.
It's just the decision not to do batch. I mean, you guys seems like
Oh.
primarily processing streams, which is awesome, but the batch is, I come from a previous SIEM company where you had to deal with batch.
Okay, so the question is, I'll repeat for the crowd, and you tell me if I misrepresent you. If I do, just yell out hashtag fake news. All right, why didn't you guys go batch? Right. Okay, so you're right. We made a mistake with cap architecture. Actually, it's not so much a mistake. Cap architecture was the right path forward, but we need to be able to, because of this enrichment, because of the profiler, have more of a Lambda-style architecture where you can do enrichments via batch. And the reason why is because you want to be able to bootstrap profiles. That is an aggressive goal in the next release, actually. So we definitely hear you there. With regard to the other aspect of batch, you certainly can do batch analytics, and you'll see things like machine learning models using Spark, like actual Spark. There are use cases that are coming as well. And for doing things like importing data into HBase, those are MapReduce jobs and Spark jobs and things like that. So it's a mixture of batch and streaming. It's a stream-first architecture because you want to get the time to insights being relatively low. Also, we store the data in HDFS. So for follow-on more advanced queries that you want a longer time window look back, what you would do is pin up Hive tables or Spark jobs that analyze that historical data. Does that make sense?
Yeah.
So we're fitting in the architecture. We just got to the stream first. We're filling in the batch now.
Because a lot of customers have backfill data.
Totally.
That get loaded.
Yes. Backfill is something we get a lot of questions about, and it's very, very important.
So as a follow-on to that, that's
Yep.
what model as a service is about, right? Is I can create a model, put it in Yarn, and then run a batch over.
Yeah, so you would train the model periodically and manage the model, and you would deploy the model with model as a service and interact with the model as the data streams by. But that's what model as a service is about. And you'll see more of that style of enrichment, the more advanced data science enrichment, coming in the next month or so. I got a pull request out, actually.
So I can do machine learning against streaming data, not just statistical analysis you're talking about.
Yes.
In the future or now?
Now. So what you would do is you would train your model on your historical data on the HDFS, build your model. That's one way to do that enrichment. That's a way to it's a way to do that enrichment, right? Where it's, all right, it's my machine learning model. I'm going to deploy that. I'm going to interact with that machine learning model as data flows by. Does that make sense?
Yeah.
So we're trying to fill in the gaps there. Yes, sir.
Just want to know the relationship between the data structure and the metadata. Is that a kind of application based on the metadata?
So what's the relationship between, I'm just going to repeat the question. What's the relationship between data sketching and metadata? Okay, so data sketching is actually not necessarily related to metadata. It's except in the sense that sometimes we ingest metadata inside of Metron, right? As you see from the example, you choose what you're going to sketch. We do not impose, we do not say this field you're going to get a statistical baseline from. You know, the reason why we don't do that is because if you look at this example, I mean, it's a relatively complex situation here. I want to understand, you know, I want to get a sketch of the distances and things like that, but I also want to get a sketch of, I also want to, you know, specifically say, okay, this is a statistical baseline with this parameter, et cetera, et cetera. Now, of course, this will become a lot easier to construct once we have a UI around it, which will be also out very soon. Because this is an important approach here. But it is, you're actually constructing the sketches from the actual data, not just metadata. Okay? Yeah.
So
One more, yes.
Good. I guess I'll ask a question ask first. So if I were actually building something like this, which I am, and I need to troubleshoot this, what do you recommend?
For this?
Yes.
Okay, yeah, so we have what's called the Stellar, right now we have the Stellar REPL. So you can actually construct profiles and simulate data running through them and see how they interact. So we have a debuggable layer there. I'm not showing that, but it is a way to say, okay, I'm going to create this like mock profile. I'm going to send data A, B, C, D, through, you know, et cetera, and then I want to grab it and say, and then inquire, like, okay, what's the sketch and what's this look like? So you can kind of understand that.
What do I search for? I guess I assume it's on your site.
Yeah, so it's through the REPL. We also have a Zeppelin interface for that. So you can use Zeppelin or you can use a command line REPL. Yeah, REPL. Stellar REPL, REPL, read, evaluate, print loop. Yes.
Hi. What do you actually use for data sketches? Did you build your own? Are there any libraries using that in the open source?
For data sets?
For data sketches.
Oh, data sketches. Okay, yes. So it's kind of a mishmash. We use tdigest from we use the Ted Dunning library for tdigest for that, for tdigest. From Bloom filters, we're using the Google one, but we're considering adding like counting Bloom filters and things like that. So we're looking at that library for the Yahoo open source a while back. Yeah, that one. So we're looking at integrating with that. We're trying to we're considering like standardizing on those things. But since they're in the wild, we didn't want to upheave. We didn't want any upheaval. For HLLP, we used.
What is HLLP?
Yeah, hyperlog plus for cardinality, set cardinality.
What is the plus? Is it like a better error rate?
No, it's so the hyperlog log with some modifications, a more recent version of hyperlog log that's slightly more efficient.
Okay.
And I can't remember the name of the library that we use. It's like it's from something from ClearSpring, if I'm not mistaken.
Okay.
Does that answer your question?
It does.
There's other stuff that's added all the time too, depending on what I deem as important right now and what users want to use. Any other question? Well, these have been good. Thank you for those are great. They're great, like a mix of like practical questions, very good practical questions. That's fantastic. All right, so how many of you are using Metron right now? Okay, you guys win. You can win. It's easy. All right. I think we're done. And come up and see me if you have any other questions.